Hi, 5th graders! Happy Sunday! I hope you guys are having a great weekend. I'm coming in from my Soul Cycle classrooms. I mean, not classroom, class. So I'm going to wear a sweater. Love Soul Cycle, as I've told you guys, and the message from our classes today was to give love and get love. And that is something, oh, you want to say hi, Cal? That is something that we constantly talk about. So I just wanted to share that message with you guys. Just remember, what you put out into the world is what you get back. So, give love and get love. It's very simple. So we're going to get into our lesson. Our lesson today is very similar to what we were working on Friday. We're going to continue looking for those common denominators using the modeling, bless you. And we, the only difference with our lesson today versus Friday is that the sums are going to be improper fractions, which you guys know are fractions larger than 1. Oh yeah, I'm in my playroom, by the way, if you're wondering what this chaos is all around me. Oh, and I put up Valentine's Day decorations because it was really sad to take down the Christmas decorations. And we're going to talk, I'm just going to explicitly give you a really good visual of the difference between columns and rows because it's so important that you know that difference. Hey, Cal. Hey, Cal.
Ooh, ice cream!
Do you want to say hi to the 5th graders before we sign out here and get into our lesson? Come here. He sends his best regards. He's very busy playing right now. Georgie, do you want to say bye-bye?
Pick a slide and put it on the
Say bye-bye. Bye. Okay, let's get into our lesson here, guys. Here we go into lesson 4 on 1/6/19, my sweet nephew's birthday. Happy birthday, buddy. We are going to, I'm just going to write out the expressions. They're pretty simple expressions instead of kind of taking the Eureka text in. So for our first problem, we're going to be looking at 1/2 plus 3/5. So something else that we talked about in class on Friday is to make sure that you have a nice large rectangle to work with. Because if you start off with a microscopic rectangle, then unless you're Ethan, you're going to have a very difficult time modeling within that rectangle, especially as our denominators get larger and larger. Okay, guys, so we have 1/2 plus 3/5 columns, then rows, and then we'll switch it up once we have our original fractions represented or modeled. So I'm going to break this rectangle into 2 because that is the denominator, and I'm going to shade in 1 out of 2 because 1 is the numerator. And recognize that those are columns. And now for our second fraction, I'm going to cut this baby into 5 rows because the denominator here is 5. 1, 2, 3, 4, 5. And then I'm going to shade in 3 of those rows because I'm representing 3/5. 3 of these rows are shaded out of the 5 total. And notice how I'm hopefully trying to use a darker stroke with my rows and a lighter stroke with my shading. Okay, so now guys, we have 1/2 plus 3/5. We cannot add these fractions together because the denominators are not alike. Our goal in all of this work is to reveal common denominators, meaning we are taking 1/2 and 3/5, and we're converting them into equivalent fractions. We're looking for something that's equivalent to 1/2, but has a more friendly denominator so that we can add that 1/2 to the 3/5, and this is how we do it. So we did columns and rows. And now what we're going to do, I'm going to mark CR next to 1/2, meaning columns first, then rows, and then next to my 3/5 we did rows and then columns. So we have CR, columns, rows for 1/2, and now we're going to do rows, columns for 3/5. So first I did my columns, okay, so check. Now I'm going to lay rows on top of my columns. How many rows am I laying on top of my columns? Well, I'm laying 5 rows on top of my columns, the same amount of rows that we had in our second model there. So we started off with 1/2, we started off with 2 columns. Now we're laying 5 rows on top of that. And again, the reason why we're doing all of this monkey business is to reveal a common denominator. So now I've laid my 5 rows on top of my 1/2. Keep in mind the rows go like this, and then the columns go like this. Now what we've revealed with the magic of math is that 1/2 is equal to, now how many shaded boxes do we have? 1, 2, 3, 4, 5 out of how many boxes total? Well, I have 1 column of 5 and another column of 5. That's 10. So we've revealed that 1/2 is equal to 5/10. Okay, I like this. Now, okay, let's look at 3/5. We had our rows, 3/5. Now we're going to lay the columns on top of the rows. How many columns? Well, let's look to this first denominator. 2 columns. I can do that. Okay, so now we started here with 3/5. We've laid our columns on top of our rows to reveal that we have how many shaded boxes now? 1, 2, 3, 4, 5, 6 out of how many boxes total? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Beautiful. So now we've shown that 1/2 is equal to 5/10. 3/5 is equal to 6/10. Now we can get down to some addition by rewriting our fractions with their new and improved common denominators. So now our expression is 5/10 plus 6/10. Hot dog, I can do that. 5 plus 6 is 11 over 10. Okay, good. So beautiful, beautiful. You guys are recognizing that this is an improper fraction, meaning this number is greater than 1 because the numerator is larger than the denominator. So we're going to cruise through that skill that we were working on in lesson 1, and we're going to decompose the top. Decompose means to tear it apart. So let's look at 11/10 is equal to, it might help to do this. We can break 11 into 10 plus 1. So we can rewrite this fraction, 11/10, as 10/10 plus 1/10. Do you guys see how 10/10 is equal to 1/10? No, you do. And now we're just going to simplify it even further, knowing that 10/10 is equal to whole number 1, and then just bring down that 1/10. So what we've done, you guys, is we simplified this improper fraction to a proper fraction, which is actually a mixed number. It's very fancy. So now 11/10 has been converted into a very proper mixed number, 1 and 1/10. That is our final answer. Raise your hand if you're having fun. Me, I am. Great, let's look at another one, guys. We are looking at a little bit more complex numbers here. We have 2/3 underneath the columns, meaning that this first fraction is going to be modeled with columns first. And then we have 3 plus 3/7 underneath the rows because our second fraction is going to be modeled with rows. And then I have CR next to our 2/3 because we will be doing columns, then rows. And then on our 3/7 we have rows, then columns. Again, we're doing all of this magic to ultimately get our denominators, 3 and 7, into a more friendly place. Right now, I mean, they're lovely numbers, both of them, but we cannot add 2/3 and 3/7 because the denominators are not the same. It is not possible until we convert these two lovely fractions into equivalent fractions, meaning another form of themselves that just happens to be the same number as the denominator. Okay, and here's how we do that. We are so lucky to have this amazing curriculum that we don't just mindlessly do some sort of calculation without any meaning. We are fortunate enough to have this beautiful curriculum where we can explore what it means to find a common denominator. I was not lucky enough to learn this way. When I was in 5th grade, I bet your parents, well, not bet, I know that your parents learned it kind of the old way, just like I did, but I'm just thrilled that we get to sort of dig deep and understand really what it means to find a common denominator. So here goes, 2/3. We are looking for columns in our first fraction. Columns look like this, just like the columns in the Parthenon. So I have 1, 2, 3 columns made because that is our denominator. And now I'm going to shade in 2 of my columns with a lighter stroke so we can see 2/3 very clearly there. I'm going to go ahead and write 2/3. Great, and now we have 3/7. So we're looking for rows in our second fraction. So I need to do my very best in, oh gosh, I'm huffing because I'm afraid I've made them too thick. 1, 2, 3, 4, 5. Ooh, I think I've done an okay job. I have 1, 2, 3, 4, 5, 6, 7. Beautiful. Okay. So I have 7 rows, and I'm going to shade in 3 of those rows. Why is she shading in 3 of those rows? Well, because 3 is our numerator. This represents 3/7. This represents 2/3. I'm going to write our originals in blue and then switch it up. I don't know, maybe I'll just grab orange because those are Bears colors and Bears games today, no big deal. Okay, so now we've done our columns for 2/3. We've done our rows for 3/7. Now we need to go back and lay our rows on top of our columns, and then we need to draw our columns on top of our rows, thus revealing the magical common denominator. Okay, so now I'm going to put my rows on top of my columns. How many rows? Well, just look over here and see how many rows your second model had. It had 7 rows. Okay, so I'm going to lay 7 rows. Hopefully they're very even on top of this. We have 2, 3, 4, 5, 6, 7 rows there. 1, 2, 3, 4, 5, 6, 7. Awesome. So what we've done, you guys, we have not changed the shading. We've shown that 2/3 is actually equal to 2, I'm counting the shaded blocks, 4, 6, 8, 10, 12, 14, oops, I didn't shade that one very well, 14 out of, how many boxes is this rectangle separated into now? Well, I have 3 times 7, which is 21. So we've shown that 2/3 is equivalent to, meaning it's the same as, just a different version of it, 14/21. Very cool. Okay, so over here we did our rows. Now I need to do my columns. How many columns? Well, originally our first model had 3 columns, so that's exactly what I need here. So I'm going to do my best, and maybe you guys need to wink one of your eyes to pretend that these are 3 even columns. So I've laid my 3 columns on top of 3/7. Now we have revealed that 3/7 is equal to, how many shaded boxes do we have now? 3, 6, 9 out of, well, I have 3 columns times 7, 21. 3/7 is equal to 9/21. Very cool. Now we can just get down and do our math. So our new expression is 14/21, equivalent fraction that we found to 2/3, plus 9/21. That's the equivalent fraction that we found that matches up with 3/7. Can we add 14 plus 9? Heck yeah, we can. Feel free to do 14 plus 9 or any calculations on the side here. I can do it quickly and tell you that 14 plus 9 is 23. And then our denominator, which is the common denominator, is 21. Please notice that in the olden days, back when in 1990, when I was in 5th grade, my teacher was fabulous. Loved him. But our curriculum in 1990 said, oh, just teach kids to multiply the denominators. And please understand, you guys, that's exactly what we're doing, but we're just showing a really great visual. So notice that 3 times 7 is 21. Indeed, that's our common denominator. But we are being much more mindful in this progression. So bravo, Eureka. I'm imagining that you guys are noticing that 23/21 is an improper fraction. Let's break down 23 so we can convert this into something that's a little bit more suitable for 5th grade. 23, I know, can be broken down into 21 plus 2. 21 plus 2 is 23. So let's rewrite 23/21 as 21/21 plus 2 21sts. 21 21sts plus 2 21sts is equal to 23 21sts. Our goal is to make this improper fraction proper. You guys know that 21 21sts is equal to whole number 1. Booyah. And then we have our 2 21sts. So our final answer here, you geniuses, is 1 and 2 21sts. Ding, 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 ding. There's one last one here that can be very tricky for some kids. So I just want to show you what happens when we're given an improper fraction to add together with another fraction. So it's the same thing, you guys. We're going to column, then row our first fraction, and then we're going to row and then column our second fraction. Here's the deal though, you guys, 4/3. Can we show 4/3? Wow, you know, I'm just gonna start over on that one. That was not my best rectangle. Can we show 4/3 in one rectangle? Think about it. So I know this is going to be 3 columns because their denominator, dear, stand by. Oh no, I pressed the button on my pen. Oh no, it's stuck in the down position. Stand by. Oh my gosh, you guys. This darn thing. Control Z, Control Z. There we go. Thank you for your patience on that. I have this, as you guys know, this very sensitive button on my pen, and if it gets pushed, things get weird. Our first fraction is going to be divided into 3 columns. Okay, but I need 4 of those columns shaded in because I'm showing 4/3. So I just shaded in all my columns. Now what am I supposed to do? Well, you guys, 4/3, as you know, is larger than 1. So in order to model 4/3, which is an improper fraction, you're going to need 2 rectangles because improper fractions are larger than 1. So now I have 4/3. 4/3. Bingo. Cool. Now let's look at 2/5. 2/5 is our second fraction, so we are going to model 2/5 using our rows. How many rows? Look at your denominator. Denominator says 5, so 5 rows we shall have. 2, 3, 4, 5. How many rows am I shading in? Well, I'm shading in 2 rows because this second model is showing 2/5. Okay, very good. So now we are attempting to do like kind of 80s colors. I'm feeling sort of 80s, like hot pink and mint green. Now we need to find a common denominator because as these fractions present themselves right now, they have different denominators and we cannot add these fractions together until they have the same denominator. So we are going to find an equivalent fraction to 4/3 and an equivalent fraction to 2/5 by laying now rows on top of our columns and columns on top of our rows. So again, keep in mind this is 4/3. So I'm going to lay rows on top of 4/3. Keep in mind I'm not just laying my rows on top of my 3/3, I have to lay rows on top of 4/3. How many rows? 5. So I have 1, 2, 3, 4, 5 rows here. And remember, we're laying rows on top of 4/3, not just our 3/3. And we're pretending that these are all the same size. So I've just laid our 5 rows on top of 4/3, and now I need to count how many shaded boxes we have. Well, I have 3 times 5 here, so that's 15. 16, 17, 18, 19, 20. I have 20 shaded boxes now. Now for our denominator, and this is what can trick kids. It's only asking how many boxes is our rectangle separated into. not counting both boxes for an improper fraction. How many boxes is this rectangle separated into? Well, 3 across times 5 tall. 3 times 5, 15. So 4/3 is equal to 20/15. That makes sense because this is an improper fraction and so is this. Okay, let's look at 2/5. We started with rows, did that. Now we're going to lay our columns on top of our rows. How many columns? Well, 3, because that's initially what our first model showed. So now I'm going to lay 1, 2, 3 columns on top of our rows, thus revealing that 2/5 is equal to 1, 2, 3, 4, 5, 6 out of how many boxes total? 3 times 5 is 15. Cool, 2/5 is equal to 6/15. Now we can just add because we found that 4/3 is equal to 20/15. I'm going to rewrite my expression up here. And then we've also shown that 2/5 is equal to 6/15. So now we just have to do some quick adding. 20 plus 6 is 26. Our denominator remains the same. It is 15. Red alert, 26/15 is an improper fraction. That shouldn't surprise us because we started with an improper fraction. Let's break 26 down into a mixed number. We're going to do that by breaking 26 down into, so this is what I'm doing in my head, you guys. I'm subtracting 15 from 26. Oops. 15 from 26. And please feel free to do this on the side. This does not all have to happen in your head. 6 minus 5 is 1. 2 minus 1 is 1. So I can break 26/15 down into 15 and 11 because 15 plus 11 is 26. So now we can, wait, why did I do that? Oh yeah, sorry, I had a moment there. So now we can rewrite 26/15 as 15/15 plus 11/15. 15/15 is equal to whole number 1. And then we have 11/15. Oh my gosh, it's just beautiful. We're going to do this time and time and time again, over and over and over, practice, 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 and then it will just, we'll kind of get into the flow of it. So if this is seeming really scary, please watch this again. Think about your understanding right now. Are you ready to show up tomorrow in math and work on this with support? Or is your brain hurting a little bit? If your brain is hurting, that's okay. That's actually great. Please watch this video again and it will make a little bit more sense. Repetition is so important when we're learning new skills. With that, our secret word is, what are the 2 pictures that I showed you? I've shown you 2 pictures consistently through this video for a very specific reason. Here's a specific reason. So tomorrow when you're checking in secret word, you're going to share what the 2 pictures are that you saw throughout our video today. You guys have a great Sunday. Cannot wait to see you tomorrow. Looking forward to a great week. And I'll see you guys in less than 24 hours.